Hello dear students, we will start with the third chapter in Science 1, that is current electricity. Now electricity is very important for all of us. We all depend on electricity for our day-to-day life. Just think and try to find in what things we are dependent on electricity. We use electricity in almost every place. Electricity is used for even running electric furnaces, electric motors, and several instruments in various industries as well. If we speak about the domestic use, so we use electricity to run fridge, electricity to run oven, mixer, fan, washing machine, vacuum cleaner, roti makers also. So in a way, electricity is really helpful to us and it even saves our time. Our survival has also dependent on electricity only. Let us know more about electricity, how electricity is generated, and the physical terms of electricity. Now, you must have seen a waterfall. In which way does the water flows? Water always flow from certain height of a mountain towards the ground. In the same manner, flow is always from a higher potential to a lower potential. As the water flows from higher level to lower level, same way flow of anything takes place from higher potential to lower potential. Now here in this example, you will see that there are few beakers and the beakers are connected and the pipe is clamped. And in the second figure, you can see that the pipe, that is the clamp, it is open. Now what we can understand from this experiment is that in the first figure, when the clamp was there, you can see there is a difference of water in both the beakers. But when the clamp is removed, water flows from higher level to lower level. So yes, the water always flows from higher level to the lower level. Also, you will find that the water stops flowing after some time. That is because this happens when the level of water becomes equal in both the bottles. That is, there is no difference in the level. So, for water to flow, we always need a difference in level and we also need a path. So in electricity, we all know that electrons flows in them. Now as electrons are negatively charged, so the electrons flow from the point of lower potential to the point of higher potential, that is from negative to zero or positive. Now here in this example, there are two potentials, two conductors are there, A and B. A is positive and B is negative. Both the conductors are connected to each other by a conducting wire. Now the electrons that will be flow, they will flow from these conducting wire only. So now the electrons, they will start to flow from negative to positive, that is from lower potential to higher potential, that is from B to A. Now the flow will continue until the two conductors, that is A and B, they have the same potential, that is until their potential difference becomes zero. Then only the flow of electrons will stop. So now from this we can know that work has to be done against the electric field to take a positive charge from a point of lower potential to a point of higher potential. So now what is potential difference? So the potential difference is the difference in the potential between the positive and the negative terminal. दोनों के बीच का जो भी potential है, that of a cell is called as the potential difference of that cell. So the amount of work done to carry A unit charge from point A to point B is called as the electric potential difference between the 2 points, and the potential difference is represented by V. The difference in the potential causes the electricity to flow through the conductor. If there will be no difference in the potential, that is, one will be not lower and one will be not higher, then how the electrons will flow? So that is why this difference is very much important. So now what is the formula of a potential difference? So as we learned that the amount of work done to carry a unit positive charge from one point to another point is called as the electric potential difference of those 2 points. So potential difference is nothing but the work done upon the total charge transferred, the amount of charge that was transferred. So this, that is PD, is nothing but V. So V is equal to W upon Q. Q is what? The total charge transferred. The total charge transferred is represented by Q. So the formula for potential difference is V is equal to W upon Q. That is, potential difference is equal to work upon total charge transferred. Now 1 volt, or you can say 1 potential difference, is equal to 1 joule per 1 C. The unit of potential difference is S in, that is in SI system, is volt. So we say it as volt. Now next is the motion of electrons. Now you will see that if you will open any electrical wire, you will open the plastic part of the wire, you will find that inside there are many metals which are present. You can find copper wires are there. So these copper or metal wires which are present inside, so these wires, they carry the electricity, or they carry the electrons through which the electricity is conducted. So they have some free electrons in them. Now what happens is, in the start, when it is not connected, when the wire is not connected to any electrical wire, so that time the metals which are there, inside that metals, there are many free electrons which are there. Now these free electrons, they are moving in any random direction here. But as soon as we attach a wire, a conductor, that time, and we start conducting, we start to create a potential difference. That time you will find that these electrons, they start to move from negative to positive. So that means the transfer takes place from negative to positive, and in this direction these electrons starts to flow, and as they are flowing, they also carry electricity with them. So this is called as the motion of electrons. Now next is the electric current. Now an electric current is the flow of electrons from the conductor. So the flow of electrons that takes place through the conductor, it generates electric current. Now current is always mentioned by I, and current is defined as the charge passing through the conductor in unit time. So that is why current is denoted by I. And if charge Q is flowing through the conductor, then I is equal to Q upon T. So that is the current I, some electrons, or you can say some charge, that is Q, is flowing through that, and it is flowing in a particular time. So that is why I becomes Q upon T. Also, the SI unit is coulomb, and the current is expressed in ampere, that is A. So you can even express it as ampere, that is A. The charge of one electron is 1.6 into 10 raised to minus 19 coulomb. Now 1 ampere is equal to 1 coulomb per 1 second. That is, 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it in every second. So these are just the units you have to remember. Don't just go deep into it, you will get more confused. You just have to remember that I, that is electric current, is equal to Q upon T, and I is always expressed in ampere, that is A.